I believe it was a problem number 3 in section 5.6 that is asking about the probability that less than 100. So x is smaller than
Warning in progress.
100. So that's what we need to work with. And when you deal with number 100, then you are going to put these bars around 100, such as 101, which is bigger than 100, and 99, the previous. And then we need to make a picture of our question, which deals with numbers less than 100. So it goes all the way to the left from that bar, including 99. So 100 is not being taken. So now to do this approximation, I must to get this 0.5 increments, and looks like the borderline will be 99.5. So my quiz answer will be x is less than 99.5. And that's all you needed for the result, and a number of people did it perfectly fine. If you didn't do it like that, well, try exercise 4, for example, or 6, so you know that any even problem is fine, and email me your work so I can give you these points back. So let's see where we can actually use this procedure. And I guess, say, exercise number 15 is a good example here. So let me work it out. Exercise number 15, which talks about a true-false test with 100 questions. So number of questions, I always call as n, is 100. So they want to know the probability of passing, which is 60 correct answers. So put probability that x is going to be 60 or more, right? So if you got 61, it's even better than 60, or 100 out of all 100. That's much better. So question is, what is this probability that x is greater than or equal to 60? So same story again. We can either have 60 questions answered, or 61, or 59 here. And then I need to get those 0.5 increments considered. So this be either 59.5 or 60.5 or another 0.5 increments. But now we need to make a picture so that equal sign will be here, including 60 and greater. So we're going to the right. So it looks like the border value is right here. It is 59.5. So now I need to produce my favorite standard normal distribution, find a z-score, and the area to the right from that z will be exactly the same that corresponds to that value of x. So z-score formula, which is x minus mean over standard deviation, is going to be used. But here's a pair of formulas that we need to utilize because we don't have mean. It's n times p, remember? And standard deviation is a square root extracted from n times p and times q. So these two formulas is what I'm going to utilize here. And to do this, I'm going to replace them into the z-score formula. So instead of mean, I'm going to on the top subtract n times p. And instead of a standard deviation on the bottom, I'm going to have a square root extracted from n, p, and q. So this way, I'm going to start, and it looks like now I can actually get a z-score here, but the question is, what is p? And what is friend q? Well, in a case of a true-false test, means 50-50, right? 50 chances that you guess and 50 chances that you don't guess. So it looks like we get a, if you do completely by guessing, both p and q equal to 0.5. So my value of x was 59.5 minus n, which is 100, times p, which is 0.5. And then in denominator, I'm going to have a square root from 100 times 0.5 and times another 0.5. So please notice that I let calculator do all the work for me, because I can do this mentally, but what for if the calculator is not making mistakes? So I just need to go for that favorite graphing, oh, not graphing, scientific calculator, right? You just select the Desmos, the favorite, and now carefully enter these numbers, such as a 59.5 minus 100 multiplied by 0.5, and then divide this by a square root, which is extracted from 100 times 0.5 times another 0.5. So I've got a z-score, nice number, 1.9. So when you have such a z-score, then you can find the area from it to the left, right? So I need to type Triola's tables. So I start typing, it appears. So I need to go in the middle of this tables. Remember where those z-scores are. I need to find positive z-scores. So that's on the next page after negatives. So how to get 1.9? Well, there is no hundreds, so I can say it's 1.90 or 00 hundredths. So it's a first column and row next to 1.9. So I get a 0.9713, and this is going to be my area from the left side. Well, to get my area, I need to subtract from 1, right? That 0.9713, and get the answer. So it looks like this be something like a 7, 8, 2, and 0. So this is the result. So it looks like the ending of story is the same, but we just need to get a little extra step, so-called continuity correction. And a good thing about this exercise is that they all follow exactly the same way of doing. If you know how to do one, then you can do all of the exercises because they're just different numbers. So I can see what else we can use this in, and there are various areas of real life. Let's say problem number 21, the airport exercise. This one is talking about overbooking flights. So let us see what is happening here. Number 21 exercise. It wants us to check what happens with American, actually Air America, that has 400 persons that want to sit in a flight with 350 seats. Oh, that's not very good idea, right? Well, they actually noticed that the chances proportion or probability, which I call as P, that people arrive is 85%, so that I can find its friend Q, the complement, 1 minus P, right? So I subtract from 185 hundreds and get 15 hundreds. So P and Q are here. That's a good start. Now they say if they book 400 persons, so that's number of people, N, find the probability not enough seats. Not enough seats means how many people came in. Well, looks like if 350 is just enough, then we got more, right? Than 350, maybe 351 or 352, and so forth. So more than we have seats available, passengers actually came in. So please notice that in this exercise, they don't give us mean and a standard deviation. And that's why we must utilize this formula that we just used to actually produce that mean and standard deviation. And for these cases, we always deal with this so-called continuity correction. So I put this numbers 350, 351, and the previous will be 349, right? So this is how I start. And then I need to make a picture of what we are asked to do. And greater than 350 will not include 350, right? It will go all the way to the right side for the greater, but not touching 350. So we'll be actually in between of 350 and 351. And we must use 0.5 increments, and that's what I have in here. So we now get a good start. I just need to find the area under the standard normal distribution. And for that matter, I'm going to be converting to z-score that new value, and that be same procedure as we just did, but, well, different numbers. Well, our calculator doesn't care what numbers you put in it. It's just the same process. So you need to get a N and P multiplied, which is 400, right, times 0.85, 85%. And then in denominator, I have a square root extracted from, again, this 400 times 85%, and now it's also times Q, which is 0.15. So looks like I need to put parentheses in my numerator as usual, right? And, well, just calculate another z-score. So that's why I'm saying that problems are really same. They just have little different numbers. So if you do a couple of exercises like I do today in a section, that's plenty, because you're going to keep doing pretty much same calculation in each problem, nothing different. So denominator is square root 400 times 0.85 times 0.15, and we've got some kind of z-score. This is 1.470. We don't need any further because we round to 147, right? So looks like it's a tables time. The same exact footsteps, and that is nice because we already utilize these tables numerously, right? So 1,4, is that what I need? 147. So I put 1,4 for the row and then 0.7 for the column. So I see that right where they meet each other. So I need to be careful. This row meets the column is right here, 92, 92. Okay, whatever it is, I put it from the left area on the left side of that z-square. So what about the other side? Well, same as in the previous problem, I have to subtract from 1, right? That 0.9292. When I subtract this from 1, I'm going to get like 8070. You can check it with a calculator. So this is about 7%. Is it possible to happen? Well, we say if it's less than 5%, then there is no chance. But it's actually more than 5%, so it is possible that the plane is overbooked. So that's disappointing, right? And I guess that's the idea, but the chances are not very high, only 7%, but still there is a chance. So I'd like to move to the next chapter because section 5.7 we don't cover. It's actually dealing with these points that approximate distributions, so-called regression, that we don't cover. It's covered in the next part of the story. So chapter 6, next part of the story will be end of the book if you decide to continue with more statistics at 4-year school. That's where you're gonna see the stuff that we're skipping in this class. As usual, first section of chapter has no exercises in it, so we'll just discuss all these ideas and we'll base it on utilizing the story about our distributions. And the key part here is to get estimates for what we don't have. So if you're studying a population, and if you actually have no idea what is going on with it, let's say you don't know what mean is, nobody told you, you don't know what the standard deviation is, you need to somehow estimate those. So to do this, people select a part of population, right, which is called as a sample. And for that sample of size n, we always call sample sizes n, right? We can actually calculate sample mean and sample standard deviation. We did it in chapter 3, we calculated this, we did it on the test as well. And based on this mean, I can estimate population mean. And based on that standard deviation from sample, I can estimate standard deviation for population. And that's the idea of this chapter. So they actually coming up with a formula. If you remember, we already considered such a formula as x was equal to mean plus z times standard deviation. And if you have a sample size n, that standard deviation was divided by n, by actually square root of n, right? So the sample size n. Well, it turns out you can bring that stuff to the other side. So you can have the x subtract z times sigma over square root of n, and that's going to estimate our population mean. And what they're discussing is that your z-scores may be one negative and the other positive. In other words, you get so-called interval where your estimate deals with negative z-score and on the other side with a positive z-score. So they call this as a confidence or probability 95% estimate, so that 5% will be broken into 2 equal pieces because picture is symmetric, so it's split equally. And each piece will have area of 2.5% or 0.025. And using the fact that it's 0.025, they coming up with these two z-scores, which you can actually check on the table, and they actually have those z-scores here on the bottom that says if you have the 95% level of confidence, or 0.95, then the z-score is going to be 196. And that's exactly what they have for the right side, and then negative 196 for the left side. So 96. So why is that? Well, you can notice that if region here is 95% of area, then its complementary region, which is composed from two equal portions, will be 5% or 0.05, which means that each piece is going to be 2.5%. We just saw it, right? And that will enable me to actually verify that indeed 196 is a valid number by looking for the area of 0.25, which is going to appear in my previous table. Among the areas, I can actually go ahead and locate 0.025. If I start on the top, if I start up here and start to go down, I eventually see 0.02, and now I need 0.05. So it looks like it's right here, 0.0250. You see this? So the row is negative 1.9. The column is exactly 0.6. So no wonder it's negative 196. And then on the other side is positive 196. And that's what the little table on the bottom actually told me right away. So I don't really have to every time look for these scores. It's, again, just scroll down a little bit and you will see the summary little chart under the positive z-scores. So they tell us if confidence is 95%, then the z-score is 196. It also says that when you have the confidence level of 90%, then z-score is going to be equal to what? Well, 90% is above, so the z-score is 1645. So that's my use of this little table. So how about if I ask you for a little quiz to use this little table again? There is one more value here that says the confidence level is 99%. So find what z-score is going to correspond to this level of confidence. And once again, all you need is just to look at this little table and see, I guess, the last row, right? The last entry actually talks about what we need. And I guess that'd be all we need for a little quiz for tonight. So take your time and put the answer in the chat as usual. That's a little quiz for today.